Distinguished guests and audience, happy Thursday. Welcome to Marintec China Innovation Webinar 2023 with the theme, New Fuel and Energy, Lead and Contribute to Decarbonization. The webinar has invited Chris Chatterton, COO of Mathner Institute, Singapore, to bring his latest research and insights, accompanied by experts from Maersk, Contemporary Amprex Technology, American Bureau of Shipping, to discuss the potential fuel and energy to decarbon for the marine industry to meet strategic requirements from MIPEC 80. This is Jingbao Wang from Shanghai SNEMI, also senior expert of Marine Design and Research Institute of China, with 7 years chairman of ITTC Specialist Committee until 2021. It is my pleasure to moderate this webinar, which hopefully will bring you some new ideas to make better choice. In 2020, Marintec China started a marine innovation webinar on decarbon and intelligence, and 6 seminars had been held until last year. Well-known experts from the global marine industry participated in the in-depth discussions, attracting much attention from the whole industry. So far, great efforts have been made on decarbon worldwide, and the just concluded MIPEC 80 has set clear targets of new fuel and energy on GHG emission reduction by 2030, 2040, and 2050. However, the right choice of new fuel to decarbon still remains different opinions among different interesting parties, which needs clarification. In view of this situation, the new webinar opens. To start with, may I introduce our keynote speaker, Chris Chatterton, COO of Mathner Institute, Singapore. Hello, Chris.
Yes, hello.
Over the past 25 years, Mr. Chris has worked at the executive level across the energy, shipping, transportation, renewables, and chemical sectors. Before joining MI as COO, Chris managed the energy assets for leading European family office with annual turnover of $5 billion, and his core interests are in gas, fertilizer, and chemical production. The first guest speaker is Mr. Su-Yong Kao, Director of Global Sustainability for ABS. Hello, Mr. Kao.
Hi, Dr. Wang. Hi, everybody. Good afternoon.
Mr. Kao has been in the marine and offshore field with 20 years of experience of surveying, engineering, business development, etc. He has brought valuable experience in delivering sustainable, digital, and innovative projects to marine industry. The second guest speaker is Mr. Fei, CTO of Contemporary Amprex Electric Vessel Technology Limited. Hello, Mr. Fei.
Hello, Dr. Wang. Good afternoon, everyone.
He has worked for well-known shipyard and marine electric propulsion system integrator, and has long been engaged in the research, development, and engineering application of marine electric propulsion system, with more than 10 authorized patents. The last guest speaker is Karim Faris, heading decarbonization for Maersk in China. Hello, Mr. Karim.
Hello, Dr. Wang, and good afternoon, everyone.
Mr. Karim focuses on securing production and sourcing of green methanol in China in time for the delivery of Maersk new vessel. He was awarded as the Innovator of the Year 2014 by the MIT Technology Review for introducing disruptive software technologies to the global wind energy industry. Well, the format of this webinar will be, firstly, the presentation from Chris on his recent research findings and considerations on the path to decarbon. It takes about 12 to 15 minutes. Then roundtable discussions, interaction from the panelists, about 40 minutes. After that, we will take questions from the audience. If you have questions, please submit to the Q&A box on your screen. Now let's warmly welcome keynote speaker, Mr. Chris, for the presentation. Chris, please.
Okay. Thank you very much, Dr. Wang. And I trust you can all see my presentation.
Yes.
Okay. So I will launch right into it, and I'll try to touch on, I think, some of the key themes that our panelists will be also keen to dive into in a bit more detail. So my presentation, my slides, I only have 12 slides I'll share with you today, just really focusing on our insights on the market for methanol as a maritime fuel as it develops alongside vessel owners and operators, producers, ports, the IMO, Fuel EU, or such, I should say, Fit for 55 framework, and other initiatives taking place globally. So I'll start with just a little background on methanol. On the demand side, there's about 100 million tons of demand. You can see it's fairly well diversified. So methanol serves many downstream fuel and petrochemical derivative markets. Just like to point out that China is the largest producer, but also consumer. So they are clocking the highest demand out of this circa 100 million tons at around 54, 55 million tons. And then in addition to that, they are importing anywhere from 10 to 11, it's been as high as 12, 13 million tons per annum. And that's out of a total of about 32, 33 million tons traded internationally. So roughly a third of the internationally traded methanol is being imported by China, which, as you can imagine, also has some impact on the global floor price for methanol. But having said that, again, with such a broad diversification of these subvertical markets across both, again, chemicals and fuel applications, lends itself well to lower price volatility, as well as more predictable supply, and again, consistent quality as it's traded under the IMCA standard, which I'll touch on again a little bit later. But due to this legacy activity around petrochemicals, very robust, you could say, fleet of established trading hubs, where there is numerous bulk break movements, swaps, blending can be performed, and there on the back of that, very transparent contracts, price assessments, as well as adherence to standards, safe handling, and generally facilitating global trade of methanol, where it has been traded for about 50 years in a seaborne manner. So these are well-established hubs and terminals. More recently, we did a little bit of a deep dive to consider out of those trading hubs, where can we identify amounts which would be in a position to directly support methanol bunkering in a maritime application. And we came up with over 115 ports actually, and we stopped counting. So it's widely available physically in its conventional format, which outside of China is largely based on natural gas and steam methane reforming technology. So going forward, where do we see the demand for methanol? And you can see it's again from one end to the other. We've got maritime to chemicals, aviation, power, and even as an energy carrier. But the maritime application is considered to be the highest trending application at the moment, and then following by methanol as a hydrogen carrier or as an energy carrier, and then we expect to see more movement around the methanol to jet application, and that appears to be building, and we expect a bit more movement on that by 2025. Why is methanol being taken up or being considered, or why is it being explored by even shippers, aviation, and say for fuel cell applications mainly? Because of its clean burning characteristics. So these are all transitioning into clean fuels. There's a need to introduce cleaner fuels globally, and methanol, again, based on the existing infrastructure, a lot of which can be repurposed to serve those markets. And again, there's a significant opportunity due to the numerous potential pathways for the production of biomethanol or e-methanol. As you can see here to the right, so much potential that it led the International Renewable Energy Association in 2020 in our joint study to suggest that by 2050, we could be seeing upwards of 550 million tons of combined specification product. And you can see, based on their forecasts, the needle for fossil-based methanol doesn't move much over the next 30 years, but what is increasing is biomethanol initially, and then on the back of that, e-methanol or electrolysis and carbon captured methanol. So that's led to all that, I guess, is you could say, has led to a significant uptake in the new order book. And this is just a glance from yesterday. There might be a couple more vessels in here that they may have missed, but by and large, these are 65, 66% liners, and then we have a kind of a smattering of other vessels in there as well, bulk carriers, car carriers, as well as tankers, of course, and it's being explored by practically all vessel types at the moment. So, and this one point I'd like to make here is that you see there's some very active interest, and that's leading to a potential, significant potential demand for the fuel in any specification, based on some basic calculations. If all these vessels, when they come into service, say over the next 3 years, we expect to see potentially, upwards of 17 million tons of additional demand coming to market. So this is something to keep your eye on as it is made available. We're tracking this buildup of additional capacity. We're fairly well on top of the existing capacity globally. This is a map detailing in a little bit more granular way the bio as well as e-methanol plants. Most of these are fairly small compared to their traditional brothers plants. So these are world-class facilities at 5,500 tons per day compared to these smaller demonstration pilot plants, which are coming, and they're at various stages of production, build up, or even still maybe involved in permitting. But having said that, we expect that by 2027, we should be able to bring collectively on an aggregate basis a combination of e-methanol and biomethanol to the tune of 8 million tons per annum. So we're working now on how can we consolidate this potential capacity how can we optimize it with maybe shared feed or collaborate on technology platforms, EPC providers, and even in the logistics of getting those small parcels to methanol bunkering hubs or terminals. But in any event, there you can see there's a definite transition taking place. And that's also very important to note. On the left side, there's a small graph just to give some benchmarks as to the overall level of ambition to reach net zero emissions as close to 2050 as possible on an LCA basis. Those revised targets, gateways, if you will, by the IMO. So in red, they're a little bit more robust, a little bit more aggressive. That provides us with a bit more direction and a bit more focus on this transition. And we see new applications, new platforms, and new technologies coming to market. New nuclear is one that is receiving a lot of attention in the press. How far it will go, we'll see, and how fast it can come, we'll see, but it can definitely be a contributor. So with that in mind, we're of the impression now that we really should start with what we have, which is conventional methanol, and then we can move into, say, blue to green, and from a production perspective on a mass balance basis, and then from a consumer perspective from the ship side, on a book and claim basis. It's maybe the only way we can backfill these gaps in logistics, as well as on the production of this fuel itself. We've got a long ways to go, and technically, and not a very long runway to get there. So it's going to take some fuel blending, it appears, for us to get there. On the back of that IRENA study that I mentioned from 2020, Roland Berger also did a little bit more of a deeper dive and came up with some additional capacity, some additional demand that would need to be addressed, approximately 39 million additional tons, and that largely coming from biomethanol to start, but also again leaning into e-methanol later. And most of that is expected to be picked up through aviation and the methanol to jet application. So having said that, we have begun with almost 200 vessels on order, and a number of vessels already in service. We've begun to train up crews. We launched initially together with Green Marine, an MI member company, and working with Singapore Polytechnic and IBIA on the local as well as the global level. We began to already offer online training as well as physical training, and this goes in line with the development of standards. You can see that methanol as a fuel application has quite a long reference in motor vehicles, in fuel cells, cooking stoves, industrial boilers, and a few other applications in reforming to hydrogen. So we have quite a bit of material data and performance data to draw from, which had enabled MAN particularly to develop their ME-LGIM platform based on an IMCA standard. And then taking that standard forward to where it could be adhere to bunkering guidelines, and again provide a basis by which contracts could be transparently concluded. The IMO mandated the ISO to develop a maritime methanol grade standard, which on the right side of the screen, you can see there have been 3 specifications developed by the ISO working group. Those 3 standards look like they will be confirmed a little bit later this year and introduced back to the IMO for adoption and implementation. And then fast forwarding to the bunkering, the here now, we had one such demonstration here in Singapore together with the first Maersk feeder vessel, methanol fueled, together with OCI and Honglam bunkers here in Singapore. And those demonstrations, transfers were made on the basis of the methanol bunkering technical reference, which was developed in 2020 by Methanol Institute, Lloyd's Register. More recently, there are more localized technical references for bunkering being introduced. In the middle document here is a draft of the English version from the Port of Shanghai. That was also done together with other key stakeholders, ship owners and methanol producers, basically. So in summary, I'll just leave you with this final slide as a bit of a recap. So again, about 190 vessels coming, 25 of which are in service. Now we have quite a good representation. So not only containers, but more bulk carriers, chemical tankers, of course. Those were the represent the initial uptake of these dual fuel engines, but now also ferries, harbor crafts, and many others, with Maersk planning to unveil their next generation design vessels. I think the first one is due later in 2024. And more recently, retrofits are now being actively pursued as a way to, again, debottleneck at the yard level. And that activity has prompted other OEMs to enter the market. So we've got quite a good representation across all the major yards, and now all the major OEMs. That has led to additional forecasts for calling for up to 1,200 of these new dual fuel methanol vessels by 2030 as a forecast, which would mean that we will still have quite a ways to go before we get to get into a position where we can fully address a carbon neutral 2050 and maritime's contribution. So we can see here it will take most, if not all, of these fuels working together. So there's no silver bullet, as we like to say. Maybe it's maybe something more like silver buckshot. We've got every fuel represented here, and we still will likely not be able to meet that 2050 carbon neutral target. But there's every indication we can come very close, if not hit it, if we're not aggressive. And if we stay true to cause, and if we were able to perhaps adopt what we have available today, and again, not sacrificing good for excellent, for something that we have no visibility or not enough visibility over when it will be available. So a bit more demand we expect by 2027, and we hope that by then we'll see much more activity. But this should get us to the 2030, the near term target by IMO. So that's the end of my presentation. Thank you very much, and I will turn it back over to you, Dr. Wang.
Oh, thank you very much, Mr. Chris, for your enlightening presentation, and also valuable contribution from MI to emission reduction of shipping. Now, let's move to panel discussion. Well, as Mr. Chris mentioned, we need to have a better understanding of advantages and also disadvantages of new fuel and energy before larger scale promotion. Then may I suggest we start with Mr. Cao, who would like to share thoughts on the presentation, then followed by Mr. and Karim. Mr. Cao, please.
Thanks, Dr. Wang, and thanks, Chris, for the presentation. I think it's very insightful, and I do agree with what Chris has presented. Methanol is one of the many fuels considered on the maritime industry journey to decarbonizations, but of course, it's depending on how it's been produced. Of course, it's not a straightforward path to near term of adoptions as some alternative fuels. But while methanol offers a relative mature path in a sense to adopt compared to other potential alternative fuels like ammonia and hydrogens, I believe various challenges in the market or rather ship owners is still accounted for, especially in the productions, transportations and storage, and also the utilizations. So from ABS point of view, I think we had various participations with regards to the dual fuel, multiple methanol fuel projects covering container vessels, bulk carriers, and tankers. But we are proud to say that within ABS, we had the guidelines that is being produced or rather published in July 2020 on for methanol and ethanol fuel vessels. So this guide actually sets out on classifications requirement for the arrangements, constructions, installations, and of course, the survey of the machinery, equipment, and system of the vessels operating with methanol as a fuels, with a focus of minimizing the risk to the vessels, crew, and also the environment. So any vessels that are eligible for using methanol will be able to receive a low flash point fuel ship notations when they arrange to burn methanol as a propulsion or auxiliary purpose in accordance with the guideline itself. So I think that perspective from ABS or from my own personal point of view, I think it still requires the whole stakeholders to come in together with all hands on deck to select the alternative fuels to actually move on with the ship owner and all the stakeholders in the market itself. Yeah, so I think that's from my perspective. Over to you, Dr. Wang.
Thank you very much, Mr. Cao. Yes, it's really very important to minimize risk, and also joint efforts are needed from different stakeholders. Okay, now next, Mr.
Thank you, Dr. Wang. And yeah, thanks for Chris' very interesting presentation about the application of Macelo in maritime. For sure, we agree that Macelo will be one of the choice for the future marine fuel. But from my understanding, I have two concerns. First is about the energy density of Macelo compared with the traditional conventional marine fuel like diesel, like LNG. Macelo has a little bit lower energy density, so that means it needs a bigger, fuel tankers in the vessel. And another point is that if you look at the emission of Macelo, it still has carbon oxygen in the emission, and the reduction of carbon emission is about 10 to 15% compared with conventional diesel fuel. So that's still a bit limited. So yeah, that's two points from my side. But I do believe that with better solution on those shortcomings is still a very good choice for the future. Thanks.
Okay, thank you very much, Mr. The question you raised about the low density and also still contains some carbon dioxide. Yes, I think Mr. Chris will have some remark after Mr. Karim. Well, Karim, your turn.
Yeah, thanks, Dr. Wang, and thanks, Chris, for the great presentation. yeah, it gives us, of course, a lot of insights on where the market is now in terms of the whole methanol fuel supply and infrastructure readiness. I think from our perspective, I think everyone knows that Maersk has taken a big step towards green methanol, especially in the current decade. When it comes to the next few years, when it comes to operational, it will be exclusively green methanol. Who future will tell, and of course here there's a lot of ongoing work, especially with the engine manufacturer, on what would be the next fuel for the next decade. But in the current decade, it's very much methanol. I think here, when Maersk started its decarbonization journey, of course, we started with evaluating all the energy efficiency measure, because there's two ways of decarbonizing. One is to increase your energy efficiency, meaning that basically you just use less energy for the same work, meaning that you emit less CO2 for the same amount of work load. But soon enough, we realized that there's there's a limit to what you can do with energy efficiency, no matter if it's through optimizing your network, your vessel speed, etc., etc. In other words, by relying only on energy efficiency measures, we would have never reached the Paris Agreement as a company. And to be in line with this 1.5 degree reduction targets, we needed to have a major breakthrough with some alternative fuel that are carbon neutral. And this is where actually methanol took a major role. So this is where we are right now. And as Chris mentioned, we have our first feeder vessel. So I'm happy to also tell everyone that we're actually on time on the vessel delivery timeline, which of course creates a lot of pressure on getting the fuel on time. But yeah, that's it's happening. And next week we will have an important name-giving ceremony of the very first green methanol vessel that will reach Copenhagen, where our headquarters is located. Thanks.
Okay, Mr. Karim, yes, also very encouraging news. And also just you mentioned energy efficiency is really very important. I believe new fuel will play a major role in emission reduction. Before Mr. Chris comment all the remarks from our panelists, may I also ask our audience, if you have any questions to our distinguished guests, do input in chat box. Okay, Mr. Chris, what is your comment on all these remarks from our panelists?
Well, yeah, I can just maybe add that to Karim's and our colleague at ABS that they worked really diligently, I think, to make that first vessel happen with I would say limited information, and they really had to put a lot of effort into making that project happen. So it was really a landmark event and a significant milestone actually in the development of methanol in the maritime application. And then of course their larger order really again contributed significantly. So that was it was a major milestone. And then bunkering that first feeder vessel was again another major milestone, demonstrating that the market is ready. It can be bunkered. It can go full circle from the technology provider to the yard to the bunkering, and now it doesn't seem like there's much more that needs to be put in place other than getting people trained up and ready for the delivery of the coming vessels. And I just made a very brief note as to, Maersk's innovative new design for some of the newer vessels that they are expected to take delivery of. But yeah, these are very efficient and much more efficient than any of the conventionally or alternatively fueled vessels that are on the market today. And they will be powered with methanol. You can go online to see more about these vessels, but they are also, I think, game changers. And I think we'll obviously position Maersk, very high on the efficiency scale going forward. And I know ABS had a heavy hand in that. So issues such as storage, space on board, and emissions, I think we've done quite a bit to address that over the past few years. And we see now that, again, there's very, very significant benefits that can be secured just with conventional methanol, and then again moving into green methanol as we're able to bring it to market. And that's really our next big hurdle to get over is bringing this green fuel to market. So we've kind of turned the corner on the technology. The vessels are coming. Bunkering seems to be being sussed. So now we need to focus on getting that clean fuel to market. So.
Okay, Mr. Chris, thanks for your clarification. Yes, from your presentation, I also can see you have done a very interesting and very, very important work, including training to reduce the safety risk and also bunkering guidelines. These efforts are really very important for the industrial use. Well, the 2023 IMO GHG reduction strategy from international shipping clearly states, first, compared with 2008, the total annual GHG emission should be reduced by 20 to 30 in 2030 and cut by 70 to 80% in 2040. This is the first point. Second point is zero or net zero emission of fuels and energy should account for 5 to 10% of the total energy consumption by 2030. To meet these requirements, how can new fuels or energy, such as methanol, ammonia, also mentioned by Mr. Cao, fuel cells, etc., contribute? Then who will comment on this first? Karin?
Yeah, maybe just I think it's worth also mentioning that in early July, at IMO, there was this MEPC 80, and
right.
something actually great came out of this meeting, where as an industry, now we are committed to be net zero by 2050. I mean, this is a great step ahead, and that, of course, it's very much required, because it's not only I mean, Maersk will not solve the problem by itself. We need everyone on board. So that's maybe just one important point here. The other one, I mean, in terms of the how do we see the other fuels? Well, I guess first of all, it's a matter of, in 2021, when we've announced our own target of being carbon neutral by 2040. So for Maersk, it's even sooner, and it's across all our business lines, not only the ocean-going vessels, but also the warehouses, the road, the landside transportation, air freight as well. So at that point of time, it's clear that it was only thanks to methanol, I would say, that we could come up with such an aggressive timeline. And the reason is it's the only solution which is, as we speak, capable of scaling up. I would say on the other hand, it is not by design. It is not a zero carbon fuel. It is a carbon neutral fuel at best, as opposed to ammonia or hydrogen. And here, it's definitely an advantage of these two other technology. And now it's a matter of technical readiness of the engine itself, but also of the whole infrastructure. I think we've mentioned this, that the great advantage of methanol is that by at ambient temperature and pressure, it is liquid, so it can be easily stored and transported. As Chris mentioned, there's also a traditional methanol industry, so you can actually leverage all these existing infrastructure, especially close to port areas. So this is also something that is, I would say, an advantage, a clear advantage of methanol to compared with the other alternatives. But I guess whenever, I mean, in order to produce this this green methanol, you actually rely on biomass waste, and this is for sure one of the resources that will start becoming constrained by the time other industries start decarbonizing, because using biomass waste as a source of biogenic CO2 is definitely the easiest way of coming up with something which is carbon neutral. But whenever we will have other industries starting their decarbonization journey, it is easily understood that these resources will be more and more scarce. So this is where maybe alternative fuels such as ammonia and hydrogen will play a role in this maritime industry. But we could also think of another alternative, which is to produce green methanol without relying on biogenic on biomass. Sorry, and this is what we call direct air capture. With direct air capture, we can actually get CO2 which is acceptable and that doesn't rely on biomass resources. So I guess this is also something that, I mean, in terms of like, how do we see the next decade? I guess it's either ammonia or most likely ammonia, or an e-methanol that doesn't need any biomass resource.
Okay, thanks for sharing. I guess Maersk is a pioneer in using methanol, and also you mentioned green methanol is really very important. However, I also believe Maersk is also seeking the possibility of using other alternatives. Okay. Well, Mr. I so far as I know, your fuel cell has been used in some perhaps small containers. Would you please share with your thoughts on this point?
Yes, thank you, Dr. Wang. As you mentioned, my background is coming from a battery company. So just a few words about my company, COTO. COTO is a world-leading technology company innovating, battery products and solutions for EVs and for grid energy storage. So actually, the battery has been widely used in the land decarbonization. And coming back to the marine industry, as you said, IMO has set a quite ambitious goals to reduce the GHG. And I do believe that battery can also play a significant role in contributing to IMO's reduction of GHG. I just share some of my source on the how batteries can contribute to the reduction of GHG. From several aspects. First is according to the different application scenarios, we can see there are different functions for batteries. For example, the first one we can say is electrification of ships. When the battery was especially pure battery-driven vessel, the battery was used to power the electric propulsion system, so that enable the ships to operate without burning of traditional, fossil fuel. And this especially feasible for or effective for short distance or coast shipping routines. And as you said, actually this application has been used quite widely, not just domestic but also worldwide. So this is one application scenario, and there are also some others like hybrid propulsion system. So that means we can combine in batteries with traditional ICE and also other alternative fuels, and that can improve the efficiency of the ships. And in these applications, the battery can play a lot of functions in this application. For example, the spalling reserve, and also it can be used for peak shaving and used for dynamic support, and also sometimes used for strategic loading. So by those measures or those functions, the vessel can help the vessel to reduce the carbon emission and also help to save in the operating cost. In addition to those, we can also consider the application in ECA, in these emission control zones, those areas. When those commercial vessel entering into the ECA, you can switch from the diesel engine to pure battery, and then there's no any emission during entering or staying at the ports. So these are the major applications for maritime. We still have some some applications. For example, when the vessel equipped with battery together with the electric propulsion, then you are able to recover the energy during the braking or slowdown of the vessel. So that's a kind of another function. The last but not least, we can also use battery to do the energy storage for renewable energy. For example, for some small vessels, they are using wind turbine or solar panels. So when those are used, then battery can be used to store the energy for those vessels. So with those combine of those applications, the battery can still play I would say a significant role in the contributing of a reduction of carbon oxygen or GHG. Yes, that's my source.
Okay, thank you very much.
Aspects.
Okay,
yeah.
Thank you very much, Mr. Thank you for your very interesting introduction, so that we have better understanding of the battery power system. They can do a lot of work. Really, just 1 month ago, I had a chance to visit a port. Also, they had a tug using battery power for especially for, say, container enter the port. The tug will help. They use the power of battery. So I think this is also very important use. Okay.
Yeah,
okay,
exactly.
Now, okay, thank you for your sharing.
Thank you.
Then Mr. Cole, I guess you must have quite a lot to say on this, how new fuels will contribute.
Thanks, Dr. Wang. I guess Kirim and Mr. Yi has already spoken. Like what I've mentioned earlier on, I think after the MEPC 80 is already all hands on deck, you know, where there's a greater urgency for alternative fuels or to take place. The journey to decarbonization, like what Mr. Yi has mentioned, in terms of battery, is one of the energy source to power vessels. I think in Singapore itself, electrification is something that the MPA is looking forward to hovercraft in the context of Singapore context, you know, and how can it actually go forward to decarbonize the environment and also the seaworthiness for the smaller vessels. But at the same time, like what I've mentioned again, at this point of time, I think it's more on all the stakeholders coming together. In the ABS, in our Sustainability Center of Excellence, we actually use 3 approach, okay, which is the collaborations, conversations, and connections. I think this is where from evaluating the design, evaluating the commercial viability, forecasting of pricing, supply and demands of what are the fuels requirement within the ship owners, the ship route that they are doing, and what is the contribution fuel source that can be a sustainable life cycle carry on in terms of their operations. I think all these stakeholders have to come together to contribute in terms from the regulators' point of view, financial institutions, classification society like ABS, and of course the suppliers itself. So that actually form up, and that's where, you know, most vessels which have the first methanol bunkering comes in place after, I think, like what Chris has mentioned, a lot of extensive discussion behind the scenes, what can be done, what cannot be done. You know, a lot of studies has been undergoing before it actually takes place. So I think this kind of collaborations is a very good practice in terms of the joint industry program and joint development to move forward for any other alternative fuels as well. Like what Chris has mentioned in his last slides, there's no silver bullet. Okay, so I think what is the best bet within the own commercial viability within an organizations to look into, and what is the collaborations between regulators and policymakers along the geopolitics arena of play that can be helpful and be commercialized viable between any of other stakeholders. So I think this is my point of view that it can be any other fuels, but I think the collaborations part must be really very, very extensive, and there's have a lot of conversations ongoing to build that network and to build that contribute to this net zero decarbonization journey. Yeah, so over to you, Mr. Wang.
Okay, thank you very much, Mr. Kao. Regulation and the life cycle are the main items to be mentioned, and also attention should be paid. I guess ABS will contribute on this. From the IMO strategy, the challenges are really unprecedented. So still a lot of work we have to do. Well, the introduction of new fuels will be a fundamental way to achieve emission reduction targets. However, the new fuel still faces some difficulties, such as large-scale sustainable supply of green methanol and a high fuel unit price, the corrosion and the toxicity of ammonia, lacking of filling equipment, and the high fuel cost. Also, sustainable supply of fuel cell for large vessels. Well, from technical and a commercial perspective, how to overcome these shortcomings of these new fuel or energy? Who will share the solution first? I suggest Chris.
Okay, so your question is about what the new solutions will be for.
All we know, say methanol. This is the most promising new fuel for future. However, I guess still you may still have some difficulty, as your presentation says, then we are trying to find the solution from technical and commercial perspective. Could you share with us some of your solution?
Yeah, I think Karim mentioned the sourcing of green methanol, and even describing it as green, and in just my opinion, it's not exactly the position of MI, but using shades, I think, is a bit misleading in some cases, because when we discuss fuels, we should really just be considering energy content that we're taking on board. So whether it's a battery or talking about LNG or ammonia, methanol, we talk about energy content, and we talk about emissions reduction, the potential to reduce emissions. And at the moment, we don't have policy which reflects those goals or those desires. So the expectations of policymakers are based on goals, and they're bringing in, say, I've used this metaphor before, sticks, but there's no carrot, to incentivize, to make it balanced, so to speak. So from a policy perspective, we see that it exerts a lot of influence on the market. And there are green corridors in place now that are looking at specific trade lanes and specific fuels, and what could be the most optimal fuels now in 10 years and 15 years, so that we can more assuredly reach our targets, our decarbonization targets. But we really need the policy to be more effective, more concise, clearer, and with purpose. And it needs to be balanced, meaning we've been waiting on even like a carbon levy, something simple that could be done to which could serve as both a stick and a carrot. But to be fair, we have very few carrots, so there's not a lot of incentive yet, and therefore even from a producer perspective, potential producer perspective, there's not a lot of interest to supply a market where there's no demand. There's no demand because there's no policy to incentivize shippers, for example. So that's where we need a lot of support. And if we get that right, then there's much more, the producers will be in a much better position to raise money to produce this fuel. And then the second challenge is to try to get this fuel, because it's not produced at scale yet. So how can we get this fuel to markets in an efficient way, which won't significantly impact the price, the end price that consumers will pay? Because at the moment, again, because of lack of policy and lack of even demand, because one, there's no assurance that if I even purchase a dual fuel vessel, that I can even secure this fuel. If I can secure it, there's no guarantee that I can even buy it at the price that will allow me to continue to be competitive in my trade lane. So we need a more holistic policy that will reflect this, both incentivize as well as penalize those that continue to emit. So those, I think, are our two main challenges: policy and the production of this green fuel.
Okay, thank you very much for your valuable suggestion. It's really very important for the policymakers support this new fuel. And also, if you see financial, also fiscal support will be helpful for the new fuels to be put into use. Okay. Well, Mr. Karim, you're representative of a ship owner. What is your observation on this? How to overcome the shortcomings of new fuels for practical application?
Yeah, so I think, of course, I agree with the need to have all the policies up to date and supporting this. I mean, it's not only the companies such as Maersk, it's also the countries and the European Union, etc. They all have their own also decarbonization targets, right? So I think actually we're on the same boat, and we work very closely together on these regulatory issues, etc. I think what we need also is to build a trust in the entire system, because of course, especially at the beginning, there is of course what we called a green premium, which means that of course for the producing these green fuels come at a higher cost, and even by adding a reasonable profit on top of it, the resulting price is still above the market price for traditional fuel, and we're ready to accept this, of course, provided that we're relying on something which is trustworthy, and so the system, all the certification system, etc., needs to. I mean, right now, just to give you a concrete example, what I understand from the project we're working on is that the whole process, no matter if it's whenever we define a fuel as a methanol, as a green methanol, we need to look at it from a life cycle perspective, which means that we need to trace down all the way from feedstock, processing, transportation, all the way to the production plant, and then the whole process energy, plus whenever the methanol is produced, how to transport it to so that's called the life cycle, right? But the frequency of auditing this whole process is actually once a year. And so I guess here that's something where, given the advancement of technology nowadays, I'm pretty sure that there will be some interesting solution coming in to make sure that there's let's say a better way of bringing this transparency and this trust in the system. Otherwise, I mean, it will take only one or two projects that goes wrong for the whole system to collapse. So we need to be super careful, especially at the beginning on this particular point.
Thanks very much for your consideration. I completely agree with you. We are on the same boat now. So all stakeholders will make joint efforts. Okay. The next, Mr. Cao, how to over the shortcomings of these new fields? Can you share with us some of your thoughts?
Sorry, Dr. Wang, you are mentioning the corrosion and toxicity of the ammonia?
Yes, I think so. Because,
yeah. Okay, I mean, ammonia, like, is I think everybody knows is one of the considered as one of the leading contender for the fuel options, you know, offering ship owners and also operators a zero carbon tank to wake emission profile. But of course, the ship owners and everyone knows that the safety part on the risk part of this fuel is in terms of the toxicity level, requires strict handling measures, as well as the lack of perspective on the requirement. But I think on this part, demonstrating the vessels on the capability to operate on ammonia, it can be very adventurous in the market right now. So some ship owners actually, in terms of experience or understanding, adopt a wait to see kind of tactics to see what is the market moving forward, and then how can they actually get in touch with this fuel itself. But of course, at the same time, the challenges is the fuel infrastructure. You know, is there terminals ready to store the ammonia, and also the engine development? I think most of the engine makers are developing and is ready to be launched maybe by next year. But at some point, it's the cost. Even though ammonia is one of the traded commodities, but again, is still on the very gray ammonia pricing in terms of the data. So where is the route, or like what Chris has mentioned early on the green corridors? You know, where are the infrastructure? Where can it be produced? Where can it be purchased? What is the route of the ship owner that can actually bunker such cargoes? I think, and what's the pricing at the end of the day, it depends on the supply and demand. So all this is also one of the considerations whether can ammonia been uptake as alternative fuels. But again, on this part, from class perspective, we had also, ABS has also offered ammonia fuel ready notations for vessels burning on these conventional fuels, having the design's suitability to permit conversions and a future dates for other alternative fuels in terms of the low fresh point fuels or the concept within the existing class systematics as well. So I guess these challenges will still be in place for any of the types of the ship carrying as ammonia, but dedicated safety requirements or regulations, the policymakers have to come in to implement and then to pilot and then to have the safe application of ammonia fuels. So at the end of the day, I think it's also the economic of skills in terms of the value change and how fast can we actually come in, adopt and pilot to drive these alternative fuels moving forward as well. Yeah, so that's my personal point of view. Yeah, thank you.
Okay. Thank you very much for your observation. Really, infrastructure and also cost, still quite some way to go. Where Mr. Where new fuels, we say fuel cells, also still meet some challenge, especially sustainable supply. What is your consideration on this?
Yes. As I introduced, at this moment, battery are being used in the short distance shipping, and for cross ocean shipping, that's still a big challenge. I mean, for the pure battery, it's a big challenge. The main challenge for the battery, I think, like the EVs, is that the range anxiety that the customers has. So, but of course, this is a, let's say, a complex, complex questions to or challenges to be solved, because in sectors like transportation or energy storage, this actually requires a combination of technological advances and also the policy support, also the infrastructure development, like other speakers mentioned. But from my side, I think we have some strategies to address the limitation of battery technology. Number one, I would say we need continues to increase the energy density. As we all know that the primary limitation of battery is the energy density, and this affects their capacity and the driving range, no matter for EVs or for electric vessels. So we need to a bit more research into the battery chemistries, like the anode or cathode material, not limited to the material, but also in the separator material. In addition to that, we also need to consider the way of integration during the battery design. So those are the ways to increase the energy density. This is one measure. And in addition to that, we can also consider the new way of, let's say, adding energy to the battery. It can be either with faster charging solution or swapping solution. So those solutions actually has been launched and developed for the EVs recently. For example, from COTO, we have launched with 4C super faster charging solution that allows the drivers to drive 400 kilometers with 10 minutes charging. So this is a fantastic solution already deployed in the EVs, and we also have a swapping solution we call the chocolate sap. So it's a modular design that you can, the customers, you can choose the pieces of numbers according to your needs of driving range. So those are the solutions that we can also adopt to the marine application. It's quite similar. There are also other aspects we need to take actions. For example, we need to expand the infrastructure building. This, of course, needs support from government, from
policymakers.
Yeah, and one very important point is we have to pay attention to the recycling and the sustainability of the whole value chain of the battery. So
yes, life cycle is also very important.
Yes, we have to trace, as we say in the user side, we pay a lot of attention to the decarbonization, but actually we, as a battery supplier, we should not only pay attention to the user side, but also to the manufacturer phases, and also we need to pay attention. I mean, we need to trace the carbon footprint, even in the supplier side.
Excuse me, Mr. We have to interrupt here because we have many questions from our audience. Okay. Later we will come up to you. Well, the first question is for Chris. Dear sir, this is George from Power Cell Hydrogen Electrification Solution Provider. One question to Mr. Chris. What about your perspective for methanol reformed hydrogen combining fuel cell application? Chris, please.
It's a fantastic solution, and pure EV is I wouldn't say it's old school, but certainly pure EVs are by and large being superseded by fuel cell, well, hydrogen fuel cell battery hybrid systems, and we see a lot of these in other developing countries, but also a lot of this in China and in mobility, in land mobility. Also, the use of small ICEs as range extenders for pure EVs, buses, heavy duty, light duty, as well as passenger vehicles. And this technology is now going to be introduced in the US with one of our partners, E1 Marine, and their JV partners in the Port of New Orleans. So there will be one vessel coming into service. It's a tug size, but it incorporates this, and I believe it's capable of 1,100 nautical miles range, and it's an EV, but with onboard methanol reforming and carbon capture. So this is the future, and it's being implemented worldwide, I can say already. So it's quite effective, quite efficient, and it's also a technology platform that certainly you should keep an eye on.
Okay, thank you very much for your answer. We are looking forward to the new combination. Well, the second question is for Karim. Hello, expert. I'm a reporter from a media company. In July of this year, Maersk announced that it would retrofit one of its existing container ships with methanol power. How is the program progressing now? And are there any technical problems encountered? In addition to new building, I'd like to know what is the prospect of new energy power conversion, and what are the difficulties and highlights of each of these clean fuel power conversions? Karim, please.
Well, thanks for the question. Yeah, so we have basically two options. One is to order new vessels, and one is to retrofit existing ones. I guess it's also a matter of like how old is the vessel. It's true that if we're talking about vessels that are almost hitting the end of lifetime, then it's pretty easy. We just replace them by these new vessels that we've announced. But for those that are, let's say, in between, given that now we are at full speed on decarbonization, we also need to find a solution for these ones. And so retrofitting is definitely one thing we are exploring, and it's true that we have announced now that one is being retrofitted. It is possible, but here there's also, as mentioned earlier, our new design is also much more energy efficient. So when you do the retrofitting option, you're not benefiting from the energy efficiency design. So I guess that's one major shortcoming. And what was how is the program progressing? So it is progressing, and of course we will retrofit many more. You will hear many more announcements coming soon.
We
In
have
addition to new building.
Yeah.
For the second part, I'm not so sure about the so yeah, I'm not so sure I understand the second part of the question.
Oh, okay. But perhaps you can provide your answer later on.
Yeah.
Oh, okay. Because of limited time, we will move to another question. How would the IMO policy impact the adoption of methanol? If methanol still have carbon emission, wouldn't hydrogen or ammonia be more suitable under the 1.5 degree scenario? Well, I guess this question is for Mr. Cao.
Okay, I think it's a question I may not even have to answer. I think maybe Chris can also help to support on this point from the MI. Yeah, but I guess methanol do produce has some of the lowest carbon footprint in terms of all the liquid fuels. But again, like what I've mentioned, it's really up to the market and also the ship owners on what is the best alternative fuels that they decided to move on. That it really depends on the market infrastructure and what is suitable for the fleet. Example like Maersk, what are they betting on, or what are they looking after? They're after methanol in a sense. So I think any of the alternative fuels that is right now trying to pursue to do can be helpful towards GHG, but ultimately at the end of the day, it has to be a net zero. So what I say is the all hands on deck, to come together to see what is the best fuels that is viable commercially towards all businesses and also the supply chain at the end of the day. Yeah. So I'm sorry, I can't give you that silver bullet lining, or rather the crystal ball. Maybe Chris can facilitate your point. Yeah.
Yeah, I mean, you're right though. We require all these fuels. Yeah, and when we say that, that comes with some assumptions, and those assumptions are more or less as follows: that we realize we're going to have to keep polluting so that we can stop polluting. Yeah, and that means we're going to have to continue to use some of these existing fuels, as was demonstrated. If you ask the engine OEMs, they're planning to be using fuel oil till 2050. That's just the way it is. Yeah, and that's why we have a position on even carbon capture. If you look around to other industries, they're not taking such a rigid perspective because they know it's not possible. Yeah, without carbon capture, for example, there's just no way. I mean, how do you expect a steel plant or a cement plant or power generation plant? I mean, we take all this for granted. Yeah, we have roads, we have buildings, we have dams, we have bridges, We have airplanes flying around every. Do you think it's easy to decarbonize these assets? It's not. It's very difficult. Even the chemical industry, you know, we talk about using ammonia, but you know, ammonia is a fertilizer. You know, it goes into farming. You know, and so what will happen if you know, farm gate prices begin to skyrocket due to due to green ammonia, and that it's just going to be burned? It's almost touching on the food for fuel concept. So therefore, I think that we have to just be realistic and pragmatic and understand that you know, it's going to take everyone making their best effort. And I mean, we realize, okay, LNG has a you know, methane slip that it has to address. It can be tackled, but it's going to require high pressure engines and some other, you know, modifications on the front end, you know, to be able to burn it cleaner. So let's just do that, you know, but put an incentive in place to get that done and tick that box and get on to the next. You know, ammonia also has, you know, some a lot of things, you know, that could go wrong, a lot of things that have to still yet to be addressed, but that's not to say that we can't do it. We're not, you know, of course we can do it if we put our minds to it. Methanol is perhaps a little bit closer, you know, to achieving, you know, real emissions. So why not just begin with conventional methanol? Almost no NOx, you know, no SOx, very low PM, and it's less CO2, which isn't the most toxic for the environment. I mean, if we want to talk about, you know, toxicity to the environment or to humans, you know, then we have to be looking at NOx, we have to be looking at SOx, you know, we should be looking at, you know, N2O and things like this, not only CO2. So, and if we continue to debate it and split hairs, then the end result will be we'll delay decarbonization in total, and we'll all fail in the end. So we just have to get on with it. Yeah. And if you know, if that's not good enough, then, you know, again, we will fail.
Yes, right. I agree. Balanced and a thorough consideration are required, including security, maturity, sustainable supply, and also economy. These factors, I think, will help us to make wise choice. Oh, well, the last question, because of limited time, is for Mr. Very short. How the battery are charged in the long voyage? How the battery are charged in the long voyage? Because if electricity is not enough, how to deal with this situation?
Yeah, as I said, at this moment, battery, especially pure battery, are not suitable for across ocean, you know, vessels. So if we are talking about the long voyage along the coastal, then that's possible, because anyway you can have onshore facility to you know, to give the charging power to the battery or to the vessel. Or as I mentioned, we can also consider the swapping solution. That means you can have a facility onshore to just swapping the kind of modular unit of battery. Yes. So to answer to your question shortly, that we have either faster charging solution or swapping solution to solve the long voyage. But still, there is one condition, that the voyage route are along with the coastal. Yes.
Thank you. We're looking forward to your new progress. Well, time really flies fast. I have to make a very short concluding remark. It has been an inspiring dialogue. Thank you all for joining the webinar. And may I invite all of you to join me in thank Mr. Chris, Carl, Mr. and Karim for their generous sharing. I do hope today's webinar is much helpful to you all. Today's session has been recorded and will be available shortly on the Marintec China website. Audience are kindly requested to deliver seminar survey to help us to be better. Thank you all for joining us today. Wish you all safe and healthy. Looking forward to seeing you in the coming Marintec China in Shanghai on December 5 to 8. Goodbye.